Okay, friends, let's prove another proportionality theorem. This is proof number 2 of 3. So, you are given triangle A, B, C and line DE parallel to the line BC. Okay, so this is the triangle A, B, C and line DE parallel to the line BC. Now, you are required to prove, AD over AB is equal to AE over AC. Okay, so solution, the first thing is to construct. Okay, you are going to start with the construction. Okay, construction. You are going to construct or join the vertex B to E and vertex C to D to form the lines BE and CD. Okay, BE and CD. You're also going to draw EM perpendicular to AB and DN perpendicular to AC. Okay, EM perpendicular to AB. Okay, EM perpendicular to AB, and you are going to draw DN. Okay, DN perpendicular to AC. Okay, DN perpendicular to AC. Now, the proof. We need AD over AB. Okay, let me show you. We need AD over AB. Okay, so you are going to use this triangle. Okay, triangle ADE, so that you can have AD, and you are going to use triangle ABE. Okay, so that you can have AB. So we are going to use the area of triangles. Okay, so the area of this triangle over the area of the triangle ABE. Okay, this is equal to a half for this triangle ADE. The base is AD. Okay, times AD times the height. The height is EM. You always going to have the height perpendicular to the base. Okay, EM is perpendicular to AD. Okay, so AD is the base, EM is the height. Always the base is perpendicular to the height, so that this formula can hold. Okay, now this is over. Now the area of triangle ABE, okay, is half times base. Now the base is AB. Okay, AB, and the height is EM, because EM is perpendicular to AB. You can see EM is perpendicular to AB. Always the height is perpendicular to the base. Okay, so the height is EM. Now this is equal to a half and a half. You cancel. EM and EM you cancel. Now you are going to have AD over AB. Okay, so we are done on this side. Now on this side we are going to use AE over AC. Okay, you are going to need AE over AC, AC. Okay, so we are going to use the area of this triangle ADE, because you are going to have AE, and we are going to use the area of triangle ACD. Okay, ACD, because you are going to have AC. So area of triangle ADE, okay, over the area of triangle ACD. Okay, so this is equal to the area of this triangle is a half times base. Now you are going to use AE as the base times the height. The height is DN, because DN is perpendicular to AE. For this formula to hold, you have the base perpendicular to the height. Always DN is perpendicular to AE. Okay, so this is right. Now over the area of this triangle is a half times base. Now for this triangle ACD, the base is AC times the height. The height is DN, because DN is perpendicular to AC. You can see DN is perpendicular to AC. Okay, so this is equal to, you cancel a half and a half, you cancel DN and DN. Now you have AE over AC. So let me do this. Okay, so now you are done on this side and on this side. Now you are going to use this triangle and this triangle. Okay, the two triangles at the bottom. Okay, so you are going to say the area of this triangle BDE, is equal to the area of triangle CDE. Why? The area of this triangle is equal to the area of this triangle. Why? Because the two triangles, okay, the two triangles, they have a common base DE, and the height is the same. Let me show you. So the height for this triangle BDE, if you extend the base DE like this, you are going to have this line perpendicular to the base DE. So this is the height and the base is DE. For this triangle CDE, this is the base is DE. If you extend the base like this, you are going to have this line perpendicular to the base DE. So this is the height. Okay, so this height is equal to this height, and you have the same base. You understand? The area of this triangle is equal to the area of this triangle. Okay, so the reason you are going to say common base DE. Okay, common base DE, and you have the same height between DE parallel to BC. Okay, DE is parallel to BC. So you understand, when two triangles have the same base and the same height, you are going to have the area of one triangle equal to the area of another triangle, okay, because of same base and same height. Now, after doing this, the question is this ratio equal to this ratio? If the two ratios are equal, then this is equal to this. So you can see in the numerator you have area of triangle ADE, area of triangle ADE, okay, ADE in the numerator. Now in the denominator you have area of triangle ABE, area of triangle ACD. So if this denominator is equal to this denominator, then this ratio is equal to this ratio. So we have to check this. Okay, so you can see, let me show you. You can see in the denominator you have area of triangle ABE, okay, ABE. For this ratio in the denominator you have area of triangle ACD, okay, ACD. Can you see? You have a common area for these triangles, okay? You have a common area, which is this one, a common area for these triangles, the triangles in the denominator. So you only have to worry about this, the bottom part. The bottom parts are equal. We proved it, okay? You can see we proved the bottom part, okay? You can see the area of triangle ADE is included in this triangle and in this triangle, and the bottom parts are equal, okay? So you can see the area of triangle ABE is equal to the area of triangle ACD, okay? The reason is you have a common area, okay, common area of triangle ADE, and the areas of the bottom part are also equal, okay? We proved it. Now you can conclude this ratio, okay, this ratio is equal to this ratio, and the reason, always write the reason. So you have a common area in the numerator, okay, common area, and in the denominator you have this area is equal to this area. This is proved. Now you can conclude, therefore this is equal to this, this is equal to this, is equal to this, okay, and we are done. Okay, so this is proof number 2 of 3.